Hi everybody, in this video we're going to talk about variability or variation in a data set. So we've already talked about central tendency. Central tendency talks about the sort of average, the typical score. It's sort of one value to represent most of the data set. It's a very good estimate of the sort of general value of the variable, depending on the circumstances of the distribution, of course. Yeah, and they also can give us a good estimate of the skew of a distribution, particularly the difference between the mean and the median will give us a very good idea of just how skewed that distribution is, and also the direction of the skew. If you're not familiar with that, you can see the last video where I talked about that more. However, they of course are limited. They don't tell us everything about the distribution, and in fact, they don't tell us anything about the kurtosis in and of itself. So I'll demonstrate that to you in the next slide here. Right, as you can see here, we have three distributions. I've overlapped them just for illustration purposes. You've got a relatively bell-shaped curve here, a leptokurtic distribution here, and then a platykurtic distribution here. Now, as you can see, the mean, median, and mode for all three of these would be 50. And it doesn't matter what the variable is here, but they would all be the same because they're symmetrical distributions. Now, if they were asymmetrical, that'd be something else, right? The mean and median wouldn't be the same, and neither would the mode. However, the mean, median, and mode tell us nothing about the kurtosis of the distribution. In other words, just how flat it is or how spread out it is. And that seems like a very important thing to know. It essentially tells us how different the people are from each other that we measured in these kinds of distributions. So we need something that can tell us about the spread of the distribution, the spread of the values here. So one option that we can have for this is something called the range. The range is a very simple measure, and in fact it has some weaknesses in that it's oversimplified, but it's still got its uses. Very easy to do. All you do is find the difference between the highest and lowest values in the data set. So if you had a data set like this where you've already ranked it from lowest to highest, you simply take the difference between the highest number and the lowest number by saying 38.9 minus 23.4, which is of course 15.5. Okay, so in other words, the range for this particular data set, this little data set, is 15.5. And that's fine. So the range is very nice to calculate. It's very easy to calculate. However, it of course has its disadvantages. The major problem with the range is that it's concerned with only two values in the entire data set. Now that was a very small data set, but I could use one that has several hundred values. And the range would still tell me would be concerned with only the lowest and highest values. And so that's just really not nuanced enough. It's not sensitive enough. What I'd like is to have some kind of measure that can take all of the data into account. Okay. And so for that, we use something called the standard deviation. You've probably heard that before, and if you're not familiar with that, that's okay. We're going to cover that here. Literally, the standard deviation is the average difference of all of the data in the data set from the data set's mean. Okay, and that may not make a whole lot of sense. We'll go through the math in the next slide. I'm just going to continue to talk about the general principle here and what it is we do to figure out the standard deviation. Not very difficult, just takes a few steps. Right, so let's use an illustration here. Let's say that you've got a data set. Let's say that this particular data happens to be something about score of literacy, okay? And it doesn't matter how this works, but let's just say that your score of literacy relative to your age is what this particular thing is. So if you get a score of 50, that means your reading level, your reading skill is exactly where we would expect given your age. If you get above 50, that means you're reading at a higher level than we would expect of your age, and the opposite would be true of below. It doesn't really matter though. So let's just imagine that we have a data set where we have a whole lot of scores. Let's say we sampled 1,000 people or something and we got all their scores. So they're all in here, a whole bunch of people, right? And let's imagine we get a relatively bell-shaped distribution, which is probably true. We would probably get something like that. And let's just take one person. Let's say we find this person. This guy's name is Dino, and he scored a 62 on this measure. So that means he's measuring quite a bit above his reading level age. So he's reading at a higher level than his age. Now, if his score is 62 and the average score was 50, the mean score was 50, then the difference between Dino's score and that average score is 12, right? Because 62 minus 50 is 12. So in other words, his personal deviation from the mean is 12 points on this particular scale. So the point of the standard deviation is we do what we just did to Dino, but we do that to everybody in the sample, everybody in the distribution, and then we average those differences. We just take the average of the difference score. So Dino's deviation is 12. Nancy's deviation might be -6, and Tom's deviation might be -10 or whatever. So we come up with all of those deviations, and then we take the average. Although there's just a little bit more to it than that, because for reasons we'll talk about in the next one. But that's basically the idea of the standard deviation, is we take the average difference of everybody from the mean of that score, of that data set. Okay, so the standard deviation is, by definition, the average deviation of a data set from its mean, from that data set's mean. And it's a very brilliant measure. It's something that's absolutely valuable. We use it in virtually all statistics that we have, at least that have continuous variables, for very important reasons. So if you don't understand the standard deviation, it's going to be very difficult to really understand what we're doing in the more complicated statistical tests. So it's important to really pin this down, which is why I'm spreading it out over a couple of these micro lectures. All right. Yes, very useful. Okay, and it does take a few steps. As I said, it's a little bit more than simply just calculating the deviations and then the average, and then taking the average of those deviations. There are also two different ways to do it, at least two different ways to do it. One of them is simpler, and one of them is more in line with the concept of what we're doing. So we'll practice that in the next presentation, and I'll see you then. Thank you very much.